Hello, I'm Isabela Gasparini, and I'm going to present the paper COEXA, a question and model based on inquiry-based learning and social web. This paper is a result of undergraduate research developed by Claudia Pimentel, supervised by me and co-supervised by Avanilde Kemczinski. There is a need for students to have a critical social background because the complexity of the different sectors of life has demanded the development of human research to think, feel, and act in an increasingly broader and deeper way. Thus, it is necessary to look for new strategies that make students develop different skills such as critical thinking. A concept that can help students to increase participation and develop skills is inquiry-based learning. Inquiry-based learning is an active, student-centered approach where the learning is stimulated by investigation and is based on a knowledge-building process. There are several categories of inquiry-based learning, such as confirmation inquiry, where students receive the questions, the method, and the results. It is useful when the teacher's goal is to reinforce an idea previously introduced or for students to practice a specific phase of research, such as collecting data. There is the structured inquiry, where teachers establish a problem or a subject and the outline for students to address. The question and method are still provided by the teacher. However, students find the results supported by the evidence that they received. In the guided inquiry, the teachers provide students only the research question, and students use the method to test their questions and solutions. And in the open inquiry, there is the highest level of inquiry. The students have the opportunity to act as scientists, asking questions, designing and conducting investigations, and communicating their results. The social web indicates a paradigm shift from a machine-centered view of the web towards a more user or community-centered view. More than interconnecting documents, pages, or research, the social web connects people, organization, and concepts. The paradigm is also reviewed in the development and growth of a new class of web applications, such as social software, which is web-based and allows interaction and data sharing between its users and allow communication between people and groups. Social software is a concept that works as a support the creation of networks of relationships through spaces where the users can join people in their relationship circle, meet other people who share the same interests and discuss different topics, building different links. On social software, users interact, communicate, create, and share and organize content, demonstrate the opportunities and knowledge that can be generated by working together and interacting with people. To help in the definition and development of social software, frameworks can be used, such as the Honeycomb framework. The Honeycomb framework was proposed by Smith in 2007 and has 7 combs. The first one is identity. It is a unique identifier of a user in the system, a way of representing elements of a person's personality and individuality. An example is a user profile. Presence is related to the research that lets you know if a certain person is online, sharing the same environment at the same time. Relationships. It is a way to determine how users of the system relate and are related to other users, like friends or followers. Reputation. It is a way of knowing how the user is seen in the system. It can be a collective opinion of other users or a statistical measure of the system. Group. It is the possibility to form communities of users who share common interests, ideas, or opinions. Conversation is related to the research of communication between users. This research can promote both synchronous and asynchronous communication. And sharing refers to the possibility of sharing items that are meaningful and important to users, such as photos, documents, and music. The code identifies appears at the center of the framework because it is the most basic requirement of any social software. It is important to note that not all systems that use the social software concept implement all the honeycombs present in the intensity of the use of each element in the systems can vary. In general, these systems implement 3 or more elements of the framework, but end up focus on 1 or 2 of them. COEXA is a question model to be applied in education environments. Our goal is students' learning become more active and consequently that students feel responsible for their learning and develop different skills such as critical thinking. The model uses inquiry-based learning theory and social web fundamentals. The model proposed that teachers manage all the actions carried out by the students and interferes when she or he perceives the need. Teacher can create questions to students, manage the interactions, and interact with them when needed. The student can create questions to share with their classmates, and also students can answer, evaluate, give feedback, and report questions. When a question is reported, it's necessary to be reviewed, and the model suggests that other students do this when selected based on their reputation on the course environment. The main point of COEXA are the questions. They are used to create more interaction between classmates, make them exchange experiences through feedback, evaluations, and even reports. The purpose of creating and share questions is also to students research about the content provided by the teacher and become more active in the learning process. We choose an e-learning platform to implement a tool based in our model. The environment chosen was AdaptWeb, an adaptive web-based learning environment. AdaptWeb adapts the content seen by each student, the presentation of the content for the students, and also the students' navigation through the course. The concept behind AdaptWeb starts in the adaptation in a discipline. For example, the environment accepts to the same discipline, for example, algorithms and program language, to be accessed by different courses such as mathematics, physics, engineer, or computer science students. Each course will see a different structure of the discipline, changing the quantity and depth of the concepts present. The same occurs with the examples and exercise and also with the complementary materials. They are adapted to each group and each student. Our new tool was implemented in AdaptWeb environment. There are two views, the student's views and the teacher's views. Regarding the student's view, the main functionality is the creation of the exercise by students. For this reason, the first step was to create a menu item, leaving the creation of exercise easy to access and view. From the menu item, the form for creating exercises have been added. In this form, students must choose the type of question, its statement, The alternatives include quantity and which are correct, and which topic of the subject these questions should be linked to. When a student creates a question, it will automatically be available to classmates in the exercise list page. The exercise created by students are present in a separate list of exercises created by the teacher. We choose automatic inclusion of the exercise to avoid overloading the teacher, in case he or she had to review all the questions. When a student answers a question created by one of his classmates, he will have the option of evaluating the question with like or dislike, and also be able to report an error. The student can report an error of a question describing the problem found. The teachers will have a menu item where he or she can choose the questions created by the students. If the teacher chooses the managed question option, he is directed to a list that shows all the questions created by the students in the subject. In this list, the teacher has the option to delete or edit a question, and it's also able to see information regarding the number of likes and dislikes and the question creator. If the teacher chooses the reported question option, he is directed to a list that shows only the questions reported by students. He also has the option to edit or delete questions. If he decides to edit a question, it will automatically be made available to students again. The teacher can edit the statement of the question, the description of the answers, and what are the correct alternatives. We conduct an experiment to evaluate our new tool. The experiment was conducted online with the algorithm and program language discipline. It was from August 31 to September 4 last year, and we have 226 registrations. During the course period, interactions were made with students by email, encouraging them to access the content and create exercise. Of the 266 students, 185 accessed at least one content, 36 created exercise, and 11 reported exercises created by their classmates. In total, there were 78 exercises created by students and 25 reported. 50 questions were evaluated. None of them received dislike. The maximum positive evaluation with like that a question received was 11, but the average was between 3 or 4 likes for each evaluated question. The students were also able to answer a questionnaire about their participation, giving their option about the exercise system. In total, 89 students answered. It is interesting to highlight the diversity among the participants. There were high school and technical students, undergraduate and master students as well. It's also interesting to note that the experiment covered people from different areas. In addition to the technology participants who had or will have contact with program language, there were participants in areas such as gastronomy and history. Of the 89 responders, 84 were satisfied with the content and progress of the course. The other 5 reported that they expect more interactivity and more detailed explanation and examples. Regarding the students creating questions for the course, 40 students reported that they created at least one exercise, but according to the analysis made on the platform, 36 students who answered the form really created the question by the exercise system. Of the 89 students, 24 students answered that they did not create exercise due to the lack of time and time management. 34 students create exercise, and the main reason comments were the test, the knowledge acquirement, contribute to the course, participate, interact, and contribute with classmates and students and study of concepts. The other 31 students created it because they thought it was mandatory. Others did not understand how the creation process worked. Some were insecure with the idea of creating and sharing exercise with their classmates. Another question was to understand what the students thought of the dynamics and answer questions from their classmates. 66 students liked the initiative, comment that it's good to create the number of questions in the course, interesting to have exchange of experience among students. The remaining 23 students reported that they do not believe that the option is interesting because the questions are created by students and without a teacher review, they could be poorly formulated, confusing, and contain errors. It is also interesting to report that of the 78 questions created by students, only 30 were answered by at least one user. Regarding the importance of being able to report questions created by classmates, 81 students replied that they think this possibility is important, justifying that wrong questions could harm someone in learning and motivation. It's important to maintain the consistency of the course and also that the reporting of questions can help the creators of the questions to improve their knowledge. When asked the students if they thought it interesting to be able to evaluate their classmate questions, the majority with 89.9% answered yes. It is interesting to see that in the exercise system, no question was evaluated with dislike, and of all questions created. Students were also asked what they liked best about creating the exercise. It was mentioned that they liked to see it as a challenge, to have freedom to choose the type of question and the topic of the subject, to be able to contribute with the course, and possibility of interaction with classmates, and to be a new way of studying. The COEXA model focuses on increasing student interaction during the use of educational environments through questioning and consequently develop skills such as critical thinking and responsibility for their own learning. Therefore, its main proposal is to allow students to create their own questions and to answer and evaluate the questions of their colleagues. Based on the model, a tool was developed in Adapt Web environments, where the creation of questions by students and the management of exercise system by the teacher was implemented. An experiment was carried out, and analyzing the result, it was possible to notice that students thought it is interesting to be able to create exercise to test their knowledge and interaction with others. But they had difficulty with time management, insecurity, and doubts about the creation process. As future work, it is suggested that the use of the COEXA model combined with other techniques to support learning, such as learning analytics and gamification, and the implementation of other elements of the model in the tool, specifically in the social elements, because, as suggested, many students reported that they would like to interact more with their classmates. The authors would like to thank Fundação de Amparo à Pesquisa e Inovação de Santa Catarina, Coordenação de Aperfeiçoamento de Pessoal de Nível Superior e o Conselho Nacional de Desenvolvimento Científico e Tecnológico. Thank you very much.